Hey guys, Mr. Bouchard here, and I'm here to talk to you about power today and work. So, what is work and power, and how are they calculated? All right, and just a little picture here. So, if you're not familiar, this is the Terminator, also Mr. Universe, also the governor of California at one point, Arnold Schwarzenegger. One of the strongest guys. And he was one of the best bodybuilders in the world at one point. So he's definitely an example of work and power. So let's talk about what that means and why I show a picture of him. Okay, so work is defined as when a force is exerted on an object and the object moves. So in other words, Superman there holding that car over his head, he's at rest. He's just holding it there, so he's not doing work. If he picks it up from the ground, up above his head, then he's doing work at that moment. So only if the object moves is work done. It will make more sense when we do the calculation, but if the object does not move, no work is done. All right, so you'll see mathematically how that works and the way it works. If the object does move, work has been done and it can be calculated. All right, so here's the formula that you guys will be using. So work equals force times distance. Don't forget you can rearrange this if you need to find other quantities. So in other words, if you need to find force, you can move distance to the other side and force will be equal to work divided by distance. All right, because you always do the opposite operator when you're moving to the other side. Or distance can equal to work divided by force. Okay, so you can use any of those. Again, if you're given work and distance and you need to find force, you can calculate it that way. All right, now, it's measured in a unit called joules, named after a scientist, Jules Verne. Also, the other unit based on the units of force and distance is Newton meters. All right, so for short, what they did instead of writing Newton meters all the time, they developed the unit joules. Joules you also see with energy. It's an energy measurement. You'll see it on the packages of food from other countries. All right, they'll either be in kilojoules or joules. All right, to give you an example. All right, how do I calculate it? Okay, so here's an example. We have a person pushing a car. So how much work is done to push a car 25 meters with a force of 100 newtons? So all I have to do, write the formula first, work equals force times distance. Look for the units to match up to the thing you're measuring. So force is the newtons one, meters is distance. So 100 newtons times 25 meters, and the final answer is 2,500 joules. And you can just use a capital J for the symbol if you want, instead of writing out joules. Okay, now power, on the other hand, was developed to look and see whether a machine is effective. Okay, so it's basically the rate of how fast work is performed. So obviously when we're talking about machinery, we're trying to get work done faster. So this is definitely a measurement to see if the machine is effective. So what is the power of a tow truck? All right, so the formula I can use. Power is work divided by time. That's one form of the formula. So if I take my work formula, which is force times distance, you can put that on top, divided by time, and that's also power. So these are two forms of the formula. Depending on what they give you in the problem, you'll sometimes use this formula, the force times distance divided by time, or if they give you work directly, you just do work divided by time. One thing that's important though is making sure the units are in the correct things when doing the calculation. So remember, force is in newtons, distance is meters, and time should be in seconds. So just make sure everything is in the correct units and because otherwise you're not going to get the correct calculation. So with power, especially the time has to be in seconds. So if they give you hours or minutes, you're going to have to convert it to seconds. All right, the units are joules per second, or once again, they made another unit, we call it watts, which is a capital W. You can see that with light bulbs. All right, that's the amount of power being used by the light bulb each second. So that's what wattage is a measurement of. Okay, now, so how does this work? So a tow truck exerts a force of 1,000 newtons to pull a car 5 meters in 10 seconds. So once again, write the formula. So this time I'm going to use the force times distance divided by time, because I have the 3 quantities there. So 11,000 times 5 divided by 10 seconds. Okay, and if you do that, you can do the stuff in parentheses first, multiply, and then divide. Your final answer ends up being 5,500 watts, or you could write 5,500 joules per second. Okay, now, an understanding of power. Okay, remember I told you power was looked at with machinery to see if it's effective at doing work. So who did more work raking the same amount of leaves? Okay, the little boy there, or the guy with the leaf blower? Well, the answer is they're doing the same amount of work, all right, if they have the same amount of leaves. Okay, the major difference though, leaf blower versus rake, is the power. Okay, so obviously who has the power to do more work? The leaf blower. All right, and the effective thing, if you're using it effectively, it's going to be able to do the work faster. All right, and that's what companies always want. They want to complete the work faster so they could actually push more product out and make more money. All right, so that's what the goal is half the time when they make something. Okay, so again, just to illustrate why, power equals work divided by time. So if I take this time and make it less, your power end up being more in the calculation. Okay, so just a little quick review and with a little familiar story. So Big Bad Wolf tried to blow down the pigs' houses. When did he do no work and why? All right, well, the answer to that question, the brick house. All right, because the brick house, nothing moved. It was not blown over by the wind at all of the wolf. Okay, how could the wolf increase the power of knocking down the houses? Well, he could blow faster if he could. If he could blow a hurricane force wind, maybe he could take down the brick house. However, maybe something that applies more force would be the answer. All right, but that's pretty much it. So just giving you guys a little introduction to this. Now you guys will calculate examples and do examples. All right, thank you guys for tuning in, and I'll see you next time.